that it becomes really tenuous.
Let me ask you some tricky questions.
Oh,
in terms of how big they are, in terms of how, they become difficult because of how much of a romantic you are. What to you is the most beautiful idea in mathematics? Another one we can ask is, what to you is the most beautiful equation in mathematics?
Well, I mean, you see,
I may have just broken your brain. because what your brain is doing is walking down a long memory lane of beautiful experiences.
Well, you see, in mathematics, we have this idea that we have an idea of a set, right? So we have a collection of things. For instance, the set of tables, the set of chairs, and so on, or set of microphones. But it could be a set of numbers. Could be a set of ideas. Could be a set of formulas, mathematical equations. And then we have the notion of an ordered set, like the set in which there is order, which means that for every two members of the set, we will say which one is better than the other or greater than the other. For instance, all numbers are ordered. 5 is greater than 3, 5 is less than 7, and so on. But not all sets are ordered. So the set of beautiful theorems is not beautiful equations is not ordered. So in other words, there are many best equations. And so Richard Feynman chose one, which I think one of the best is that if you take e, the base of natural logarithm, to the power pi I, so you have e in it, the base of natural logarithm, you have pi I, which is square root of -1, then the result is -1. So that's up there for sure in the pantheon of beautiful formulas, that I think pretty much every mathematician would agree. I don't know what my favorite one is.
Just lingering on that one, Euler's identity. What makes it beautiful? Just a few symbols together.
Right.
I mean, part of it is actually just trying to define what is beautiful about mathematics. That is laid in there in this particular equation that is somehow revealed when the human eye looks at it. Why is it beautiful, do you think? Pi.
There is an element of surprise in it. How is it possible? We always think of pi as the ratio between the circumference of a circle and its diameter. Here, we are taking some number to the power pi, not even pi, mind you, but pi multiplied by square root of -1. Surely, this is something completely incomprehensible. And yet, the result is -1. You see? And if you take e to the power 2 pi I, you get 1, actually 1. So I would guess but in other words, the initial reaction is just that of a surprise, I guess. I guess for anyone who first comes across.
That these four folks got together.
Yeah.
It reminds me of the idea that Hitler, Stalin, Trotsky, and Freud were all in Vienna at the beginning of the 20th.
And Wittgenstein was a classmate of Hitler. You know this?
I did not know this. No.
Yeah.
So it makes you, you can imagine a situation where they're all sitting at a bar together at some point, not knowing it, but it all made sense in space-time to be located there. And that's what this feels like, some kind of intersection.
Intersection, yes. But I would say that after the initial shock, you look at the proof of this equation, and it actually does make sense. And actually it is nothing but the statement that the circumference of the circle is, and in fact, in this case, it's the circumference of a semicircle is equal to pi. And that's where it comes from.
In the end, the truth is simple.
In the end, the truth is simple. Not necessarily easy, but simple.